Second sum part A group. Find the transfer function C of S upon R of S using block diagram reduction technique. Hence, verify the result by Mason's gain formula using signal flow graph. So here, see the direction. It is passing through G3. One goes downward, another goes upwards. This can also be redrawn. One more block you can put, G3. This goes down and this goes up, and you can disconnect the link here. Both are correct, you know. The signal passing through G3, one part goes to up, another part goes down, means G2, now G2, G3 are parallel, G3, G4 are also parallel. That is the critical part in this sum. G2, G3 are parallel, G3, G4 are parallel, but G2, G3, G4 are not parallel. I understand this point? G2, G3 are parallel. Similarly, G3, G4 are parallel. Where we have to add either with G2 or G4. No, both. We have to add G2 with G2 as well as G4. Because it is parallel to both G2 as well as G4. That's why G3 should be added to both. If you redraw the circuit, what you will get is G2 plus G3. So there is no need of summing junction. Many did, they have drawn the summing junction also. Once it is added means why summing junction is, why we added to remove the summing junction. After adding, why you are drawing the summing junction? Why we added G1 plus G2? To remove the summing junction. Once it is removed means why you are drawing that G2 plus G3 and a feedback loop G1 minus, this is plus. Then G5 is there. G5. G5. This is plus. Now, this signal is coming down. G3 should be added to G4 also. G4 plus G3. But this is going to this junction. Then G6. G7 minus. That's all. Now we can apply seventh rule here. We can apply now itself. We could have applied, but I didn't apply. Now itself we could have applied here. But here you cannot apply. Here you cannot apply. Why? Why you cannot apply here? Why you cannot apply here? Seventh rule cannot be applied here. Why? Because there is a takeaway point in between. Once it is converted into single block means how you will take the takeaway point. You cannot take the takeaway point if it is converted into single block. If you convert this into single block, this is what G1. What I will get, many wrote, somebody wrote G1 wrong. This is wrong. G1 upon 1 plus G2, G3 multiplied by G. Which is forward path? This is forward path. G2 plus G3 is forward path. Not G1. It is above, you know. That's why they are writing like this. This is wrong. Which is forward path? G2 plus G3 is forward path. G1 is feedback path. That's why that should be in the denominator only. This is in the numerator. G2 plus G3 is in the numerator. But anyhow, now we cannot convert. We cannot apply seventh rule here because of this takeaway point. Suppose you are converting this into single block. Say G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. If you convert this, from where you will take this? It is converted into single block. How you will take that takeaway point? You cannot take. That's why we have to remove that first. Then only you can convert. So to remove that, we do not have any rule to move out of summing junction. Takeaway points, we can move. Under worst condition, we can move. I'll let you know later. I don't want to confuse you now. You will get one, suppose, I'll tell now, but don't apply it. Suppose I want to move this here. I want to move this here, let us assume. Then no problem. You can move here very much. G4 plus G3 will come. But this path also going through this, that is not considered. For that, you have to include one more feedback path. That's all. You have to include one more feedback path which consists of G4 plus G, which consists of this G2 plus G3. It should consist of that G2 plus G3. That's all. One more feedback path you have to include. From where it has to draw is a question. That is also there. That's why always move this takeaway point away from this summing junction. Away from this, always. So if you want to move this away means this side only, not this side, because we have no rules for that. We didn't study any rule to move across summing junction. We can move after a block. We have rule. If you move across this, it is not multiplied by G2 plus G3. That's why we have to divide. That's why I can move here. In this diagram itself, I will move. I will move. In this diagram itself, I move. Then what we have to do? Divide by G2 plus G3. I understand. Consider now red line. Don't let us remove this part. If you remove this, so I moved this point from here to here. Then what happened to the block? The block becomes G4 plus G3 upon G2 plus G3. Am I correct or not? Because it is not multiplied by this. Now it is multiplied. That's why we should divide by G2 plus G3. That's all. G2 plus G3. Now we can convert this block by using seventh rule. If you convert this block into seventh rule, apply seventh rule for this. Seventh rule. For this also you apply seventh rule. Seventh rule. Then what you will get? For this G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. This is for first block. For this block, first block, I got this. So I have to draw that summing junction is there, R is there, feedback is there. This feedback is there. This is plus. This is plus. This is plus. I will put here. This is minus. Feedback is negative. So after this, G5 is there. G5 is there. Now this is coming here. G5 is in parallel with G4, G5. Therefore, I can add G5 with that. Am I correct or not? Can I add? Because this, you follow my pen. This red line is in parallel with the G5. Am I correct or not? This red line, follow this red line. This G4 plus G3 upon G2 plus G3 is in parallel with the G5. Am I correct or not? Therefore, what I can do is I can add with G5. So G5 plus, so what I can write is G5 plus G5 plus G4 plus G3 upon G2 plus G3. G5 plus G5. G5 plus G4 plus G3 upon G2 plus G3. Now, up to this we came. This block, this summing block can be written like this. One summing block, another summing block. In this summing block, this G4 plus G3 upon G2 plus G3 came here. Here, the feedback path is coming. This unity feedback path is coming. Unity feedback path is coming. Therefore, this G6 can be written as 7th rule. 7th rule. G6 upon 1 plus G6 multiplied by 1. G6 multiplied by 1. Why 1? Because unity feedback, no block is there. Therefore, 1. No block is there. The value is 1. That's why multiplied by 1. That's all. Now the feedback as G7 is there. G7 is there. That's all. Now we have to multiply all forward paths. What is first block? What we have? G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. This is first block. We have to multiply with that. Oh, I wrote in the previous slide. Okay, no problem. G5, if you take LCM, what you will get? G5 multiplied by G2 plus G3. G5 multiplied by G2 plus G3 plus G3 plus G4 whole divided by G2 plus G3. Am I correct or not? I'm taking LCM, that's all. I'm taking LCM for this block. If I take LCM for this, G2, G3 is LCM. That's why G5 should be multiplied by G2, G3, G4, G3. So that's all. That's all. Multiplied with, what is the another block? G6 upon 1 plus G6. G6 upon 1 plus G6. So G2 plus G3 getting cancelled. This becomes a single block. This is G7. Some students, why they put G1 upon G2, why they put, because this is G1, G7. Don't consider those suffix numbers. Suffix can be given. For this, we can give G7. Here you can give G2. Suffix number is to distinguish, that's all. It need not be in the particular sequence. Any name can be given to any transfer function. That's all. Now we have to apply 7th rule. That's all. So what in the numerator, forward path transfer function I am writing? G2, G5 plus G3, G5 plus G6. Here also G6. G6 is outside, That's why we have to multiply by G6. Then here, what you will get? G3, G6 plus G4, G6. Am I correct or not? Check whether I am correct or not. G6 is outside for all. That's why we have to multiply everything by G6. Then in the denominator, what you will have? 1 plus G1, G2 plus G1, G3 multiplied by 1 plus G6. So I am applying 7th rule. That's why 1 plus negative feedback. Here negative feedback. Here negative feedback. That's why 1 plus. We have to write as such G6, G2, G5 plus G3, G5, G6 plus G3, G6 plus G4, G6 upon 1 plus G1, G2 plus G1, G3 multiplied by 1 plus G6 multiplied by what is in the feedback, G7. Now, if we take LCM, these two will getting cancelled and the 1 plus 1 becomes this denominator part. So we can write one more step. Therefore, the final answer is G2, G5, G6 plus G3, G5, G6 plus G3, G6 plus G4, G6. 1 plus G1, G2 plus G1, G3 plus G6 plus G1, G2, G6 plus G1, G3, G6. Plus G2, G5, G6, G7 plus G3, G5, G6, G7 plus G3, G6, G7 plus G4, G6, G7. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, including this one, 10 elements. That's all. Now we have to solve this by using signal flow graph. Now we have to convert this into signal flow graph. For that, for every junction, we have to name a node, including source node and destination node. This is source node. C is destination node. So this is second node, third node. This is fourth node. This is fifth node, sixth node, seventh node. This is eighth node, ninth node. This is 10th node. This is 11th. So 1 to 7. 1, 2, 3, 7, 11. 5 is 8 is here. Below 3, 8 is there. Then 9, 10. Below 4, 9. Below 9, 10. That's all. So 1 to 2, what is the gain there? 1. 2 to 3, unity gain. 3 to 4 gain is G2. 4 to 5 no gain. 4 to 5 no gain. 5 to 6 what is gain? G5. 6 to 7 G6. 6 to 7 G6. Then 3 to 8 direction is important. 3 to 8 gain is unity. 8 to 9 G3. 8 to 9 G3. 9 to 4 unity gain. Here G4 8 to 10 gain is G4. 10 to 9 to 10 only. 9 to 10 only. Then 10 to 6 one path is there. Gain is unity. 7 to 2. 7 to 2. Gain is minus G7. 5 to 2. Gain is minus G1. That's all. Anything I missed? 7 to 6. 7 to 6 gain is minus 1. Why minus 1? Negative feedback. Here you can notice that negative sign is there. Therefore, minus 1. Now, how many forward paths to reach from 1 to 11? This is gain 1. How many forward paths are there? P1 equal to 1, 2, 3, 4, 5, 6, 7, 11. So what are the gains? G2, G5, G6. Then any other forward path you can come. Any deviation is there, you have to notice. At 3 you can come down. So you can go to 8, then 9, then 4. Therefore, second forward path is G3, G5, G6. Third forward path, you can come down here. G3, there are two paths. One go up, another one go down. Therefore, G3, G6 is another forward path. G3, G6. What is the path? 1, 2, 3, 8, 9, 10, 6, 7, 11. 7, 11. 7, 11. That is one path. G3, G6. That's all. P4, another forward path. You can come at the same point 3 to 8, then G4 through G10 you can go. Therefore, G4 will come. G4, but you cannot travel this way. But G4, G6. G4, G6. Here, G3, G5, G6 is there. How many forward paths? You can see that. If you have any doubt, you can see the block diagram. How many in the numerator? How many elements in the numerator? 4. Definitely 4 forward paths will be there. You can check with that also. Even with the block diagram reduction, you can check the signal flow graph. In the denominator, how many elements you have to get? 10 elements you have to get. Already I counted and wrote 10. So, while writing number of loops, you can check that. Okay, only 4 forward paths. Let us check whether it is correct or not. That also possible. G3, G5, G6. G3, G5, G6. It's there. G3, G5, G2. One is G2. This is G2. G2, G5, G6. That is also there. G3, G6, G4, G6. That is also there. Forward paths are correct. I can cross-check with the block diagram reduction. Now I can find the delta. To find delta, what all we have to find? Delta 1, delta 2, delta 3, delta 4. We have to find delta 1. What is delta 1? Delta 1 is is also a delta part of graph which is not touching the forward path. The forward path is for G2, G2, G5, G6. The part of graph which is not touching the forward path is 8, 9, 10. Or the three nodes are not touching the forward path, but there is no loop. 8, 9, 10 is not loop. Why it is not loop? Direction is not correct. Direction is not in the unidirection. This one-way traffic is there. That's why it is not loop. Therefore, delta 1 is 1. Delta 2, G3, the part of graph which is not touching the forward path is only 10. No loop is there. That's why that is also 1. Delta 3, G3, G6. G3, G6. Part of graph is 5 and 10. No loop is there. No loop is there. At 5 and 10, no loop is there. That's why G3 also 1. G4, G4, G6. Part of graphs are 9, 5. At 9 and 5, it has loop. It has loop. This loop is there. G2, G1 is there. G2, G1 loop is there. But it is touching at 2. Forward path. What is the forward path? 1, 2, 3, 8, 10, 6, 7, 11. For that you got G4, G6. That is also no loop. That's why that is also 1. Now we have to find delta. Delta equal to the transfer function. To find delta, we have to find all loops. L1. L1 equal to what? First loop. This is one loop. This is loop 1. What is that loop? Minus G1, G2. Minus G1, G2. This is another loop. Loop 2. Loop 2 is G6 minus G6. Minus G6. Another loop I can find. If I travel 2, 3, 8, 9, 4, 5. If you travel like that, I'll get one loop. That is L3. If I travel like this, I can find one loop. What is that loop? Minus G3, G1. That is one loop. L5. L5 equal to G2, G5, G6, G7. That is one loop. L6. L6. G3 minus G3, G5, G3, G5, G6, G7. L7 equal to G4, G6 minus G4, G6, G7. 7 loops are there. Any other loop? What are the non-touching loops? L1, L2. That is non-touching. L1 and L2. That is G1, G2, G6. L1, that is G3, G1. What is that? G3, G1, L3. L3, L2. That is also non-touching. Therefore, G3, G1, G3, G1, G6. L7 is L7 equal to G3, G7 minus. That is one more loop. Now 7 plus 2, 9 plus 1, 10. We got, therefore, the transfer function is P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 upon delta. Delta where delta equal to 1 plus 1 minus L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7 plus That's all. Plus L1, L2 plus L2, L3. That's all. I finished.